Hello young chaps, we have been discussing about all the questions which are most favorable to be asked in your board exams. Well, we have completed discussion about section A, the very short answer type questions. Then section B a bit longer, section C a bit longer, and now is the turn of section number D. Well, this consists of, as you can see, questions from 24 to 29. This is what constitutes to be the section D. These are the long answer type questions, and today we will be understanding how to deal and tackle them in a very easy, direct manner. Let's see what happens to be our first question in section D. Okay, so what is the question trying to say? The first two words which basically I was able to focus on were local maxima and the local minima. That means somehow the question is asking me to again revisit my knowledge about local maxima and local minima. Then obviously it is saying find all the points of local maxima and local minima and the corresponding maximum and minimum values of this particular function. Alternatively, a question on the binary operation is given to you. So obviously you have to attempt either this or this, whichever you feel comfortable with, and therefore we will be discussing one by one both the questions. The first question, as you can see, is asking you to find the points of local maxima and local minima of this particular function. So let's write what is the function. The function is minus 3 by 4 x to the power 4 minus 8 x cube minus 45 by 2 x square plus 105. This is my function. What are the steps to successfully attain the local maximas and the local minimas of a function? Well, the very first step is to find f dash x. This is the first thing that you have to find. So let's start finding. What is your f dash x? Well, this happens to be minus 3 by 4 into 4x cube minus 8 into 3x square minus 45 by 2 into 2x plus 0, isn't it? That's what here it is. So this is what is the derivative of this particular function. That means what is it that you get? This 4 gets cancelled, this 2 gets cancelled, and you are left with minus 3x cube minus 24x square minus 45x, correct? Now there's something that I can see over here. Well, I can see that there is some x common in all the three terms. I can also see that each and every term is a multiple of 3, so I can take out 3 common. After that, I can see there is a minus sign before every term, so why not take out minus sign also common, thereby getting minus 3x as the common term outside the braces. What you are left with after that is what? Now minus 3x has come out, so you are left with x square. Then again minus 3x has been coming out, so you get what? 8x. And over here you get plus 15, isn't it? This is what you get inside the braces. Now obviously you can see that this is what? A quadratic equation, and now over here you know how to break the middle term of this quadratic polynomial, basically I should say, and simplify this expression. So you get minus 3x. After that, you know how to break the middle term. What happens over here? X square plus 5x plus 3x plus 15, isn't it? And now just club them together. So you have x plus 5 plus 3 into x plus 5, isn't it? Once you have obtained this, you have the factors as these. This is what happens to be the most simplified form of f dash x. Now step 1 is accomplished. Step 1 always is to find f dash x when you're dealing with problems of local maxima and local minima. Once you have found f dash x, what is the next step? The next step is to find the critical points. That happens to be my step 2. And the critical points basically are nothing but the solutions of f dash x equals 0. So let's put f dash x equals 0 and see what are the values of x which we can obtain as a result of this particular equation. So f dash x is 0, that means all this is 0. That means what is 0? Minus 3x multiplied by x plus 5 multiplied by x plus 3. This is 0. What do I mean by this? This means my x is 0, minus 5 and minus 3. Isn't it? These are the values of x which satisfy the equation f dash x equals 0, and so these are my critical points. Basically, when I am saying that these are critical points, that means these are the only points which can be local maxima or local minima, or points of local maxima or local minima. That is why these are the 3 points which I have obtained, which can be, any one among them can be local maxima or local minima, but only these 3 are going to be tested for becoming points of local maxima and local minima. So step number 3 is going to actually give me that test which is going to be applicable for only these 3 points, and once these 3 points are applied inside that test, according to the result, we are going to declare them as points of local maxima or points of local minima. So let's see what is step number 3. Step 3 always in this particular procedure asks you to find f double dash x. Yes, that is what we need to find at this step. So once I have f dash x, the next step will be to find f double dash x. So f dash x is what? Basically till here you had your f dash x. After that you started clubbing them in the form of factors. So till here you had f dash x. From this only I am going to get my f double dash x. So what will that be? This will be minus 9x square What is the next thing? It's minus 24x square. So this will be minus 24 into 2x, which makes it a minus 48x. After which you have what? Minus 45x, which just delivers you with a minus 45. And this is what is my f double dash x. Now after step number 3 is also accomplished, what is the step 4? Step 4 says test f double dash 0, f double dash minus 5 and f double dash minus 3. What do I mean by test? By means of test these 3 values, I am trying to say that give me the answer whether f double dash 0 is strictly greater than 0 or strictly less than 0. Similarly for f double dash minus 5, similarly for f double dash minus 3. Because if f double dash of a certain x naught is strictly greater than 0, that means that x naught is a point of local minima. And if f double dash of x naught is strictly less than 0, that means that x naught is the point of local maxima. That means over here we have to check whether this and this, they are strictly greater than 0 or strictly less than 0. So let's start checking them. What is f double dash 0? Now f double dash x is this, so f double dash 0 will be what? Put in place of x, put 0, you are going to get a minus 45. And this is less than 0, isn't it? That means f double dash 0 is strictly less than 0. This means 0 is the point of what? Local maxima. Yes? And if this is the point of local maxima, what is the value of the function at this local maxima, or what is the local maximum value of the function, as the question was saying, that find out not just the points of local maxima and local minima, but also find out the corresponding maximum and minimum values of this function. So, once I know that my 0 is a point of local maxima, the corresponding value of the function, which is the local maximum value of the function, this will be what? Well, local maximum value of the function fx at x equals 0 is what? Well, this is your fx. So, at x equals 0, if you get 0, 0, 0 over here, you plug in, you get just a 105, which is your answer. So, f of 0, which is 105, this is the local maximum value of the function, fine, at x equals 0. If I move to testing f double dash minus 5, what will this be? F double dash minus 5 will give me what? So, f double dash was written over here. Let's see what that is. 9 into a minus 9 into minus 5 square, which is a 25, minus 48 into minus 5, and you have a minus 45. Once you have this, you are going to find out this is coming out to be a minus 30. Once this has come out to be a minus 30, this means it is less than 0, isn't it? This is less than 0 means what? When f double dash of x naught is less than 0, that means that x naught is a point of local maxima. So, this implies minus 5 is a point of local maxima, and local maximum value of f is f of minus 5, which is what? Over here you plug in at the place of x, you plug in minus 5, you find out f of minus 5, that is going to deliver you with the output this. And that is what is the local maximum value of f at x equals minus 5. We are just left with one more test, which is to test f double dash minus 3. F double dash minus 3 means what? You have to plug in minus 3 in place of this x. You are going to get what? Minus 9 into 9, minus 48 into minus 3, minus 45, and that is going to deliver you with an 18. And this 18 is strictly greater than 0. Now this means what? This means minus 3 is a point of local minima. Isn't it? F double dash x is positive, that means that particular point x for which f double dash x is positive is the point of local minima of the function f, and the corresponding local minimum value of f, which is f of minus 3, becomes what? Well, just in place of x you have to substitute minus 3 and solve this entire expression. What you are going to get is your local minimum value of f at x equals minus 3, which is this. And that completes my discussion about this particular question, which was what? Basically, it was asking you to find the points of local maxima and local minima, and also find out the corresponding maximum and minimum values of this function. So we just used our algorithm, which was to find f dash x. Then we equated f dash x with 0 to find the critical points, the points which can only qualify to become the points of local maxima and local minima. And then we used our second derivative test, basically. F double dash x was what we found, and we plugged in each of these values found in step 2 inside f double dash x in place of x, and we found if those were strictly greater than 0 or strictly less than 0. If it was strictly greater than 0, we declared them to be the points of local minima, and if it was strictly less than 0, we declared them to be the points of local maxima. That's it. Something very, very easy, very, very basic, just applying the second derivative test to find out the points of local maxima and local minima. After that, once we had decided that these are the points of local maxima, these are the points of local minima, we just plugged them in place of x and found out what was f's value at these points. That was nothing but basically the local maximum or the local minimum value of the function f. And that completes my discussion about this particular question. Now the alternate question, if you can see, is talking about binary operations. Now when binary operations are being concerned, that comes out to be as a very, very easy section first of all. Not just an easy section, but a very scoring one. Once we have completed this question, let's see what happens to be over here. This might look complicated, but it's seriously damn easy. Let's understand this. So I am given a set, which is collection of all reals, punctured this point minus 1. Collect all the reals, just puncture out this minus 1 real number, and you obtain the set R minus minus 1. A binary operation is defined between any two A and B terms of this particular set. So A star B, where A and B both are coming from this set. How are they operated? A star B is given by A plus B plus A into B. When I am talking about A plus B, this is nothing but the addition of real numbers happening. When I am talking about A into B, this is nothing but the multiplication of real numbers happening, because A and B are coming out from the real number set only. So here there is no confusion as to what is the addition and what is the product. The only confusion was that how is this star defined. So A star B, whenever two terms from this set are operated with the help of this star, the output is obtained like this: A plus B plus AB. Okay? For all A, B in this set. What is it then we have to show? Okay, this is a set. This is how the elements are operated. The question is, prove that star is commutative, first thing, as well as associative, second thing. Find the identity element, third thing, and prove that every element is invertible, fourth thing. There are 4 questions in this one question. So let's get started and see whether inside the set the operation which is defined is a commutative operation or not. So the first thing we are going to deal with is commutativity. If it is commutative, I have to show that A star B is equal to B star A for A and B any arbitrary points inside this set. Now what is A star B? Let's consider the left hand side. A star B is A plus B plus AB. And what is B star A? B star A is B plus A plus BA. Now are they unequal? Well, real numbers, inside real numbers, addition is a commutative operation. So B plus A is same as A plus B, isn't it? And multiplication is also a commutative operation inside the collection of all reals. 2 into 3 is same as 3 into 2, isn't it? So B into A can be written as A into B. They are equal. That means B plus A plus BA is same as A plus B plus AB. This means A star B is equal to B star A, and so yes, this operation inside this set of R minus minus 1 is a commutative operation. Pretty nice operation. It's commutative. It is having the property of commutativity. Let's see whether it is associative or not. That would be our next discussion. Associativity. So what do we need to check in associativity? Basically, I have to show A star B star C is equal to A star B star C for all A, B, C belonging in the set R minus minus 1, isn't it? Let's deal with the left hand side. Okay, so A star B star C. Now this is the first term operated with the second term. That means first term plus the second term plus the product of the first and the second term. So first term plus the second term plus the product of first and the second term. That's how the operation is. A star B is what? First term star second term is what? First term plus the second term plus product of the two terms. Now A star B is again A plus B plus AB plus C plus A plus B plus AB multiplied by C. Now over here, if I wish to simplify this, how can I further write this? This can be equal to A into C plus B into C plus A into B into C. Isn't it? That is what is coming out to be A plus B plus C plus AB plus BC plus AC plus ABC. Perfect. Now I wish to move to what? Let me now pick up the right hand side, which is A star B star C. Okay, so first term plus the second term plus the product of the two terms, which is A into B star C. So this becomes what? A plus B plus C plus B into C plus A into B plus A into C plus A into B into C. And now you can compare. This is also A plus B plus C plus AB plus BC plus AC plus ABC. Yes, and therefore I can say that A star B star C is equal to A star B star C, and therefore my operation is very much associative as well. That means the two claims which were asked about this operation was show that whether this operation is commutative or not, show whether this operation is associative or not. And we have found that this operation is both commutative and associative. Now the next step is to find the identity element. Now the identity element which we wish to find is suppose given by the letter E. Let E be the identity element in the set. This means what? If E is identity, this means A star E equals A equals E star A for all A in R minus 1. That is what is the function, the role of identity element. To not change the identity of the element with which it is operated. So that's what this E is doing. Now what is A star E? Consider this section. So A star E is A plus E plus AE. Right? This A gets cancelled. You get what? E times 1 plus A is 0. Now if the product of two terms is 0, both of them are real numbers. Either this is 0 or this is 0. But if 1 plus A is 0, that means A is minus 1. But A is not allowed to be minus 1 because A is coming from R minus 1. So A cannot take and assume value as minus 1. That means 1 plus A is not never 0. Therefore, for this product to be 0, E has to be 0. And so we obtain that 0 is what is the identity element, and 0 is very much sitting inside R minus 1. And so I have obtained an element inside the set which on being operated with any element does not change its identity, and therefore E equals 0 is my identity element. Let's move to the fourth thing that we have to find. We have to prove that every element in the set is invertible. Every element is invertible. There exists a B corresponding to every A such that A star B is equal to B star A equals identity. So let A be any element inside the set such that there exists some B inside the set such that A star B is equal to B star A equals identity. That's what is the role of inverse. If B is the inverse of A, both of them should first of all be in the set which is there in the picture, in the context, and they should satisfy this particular thing. Now E, I know that it is 0, so here I am going to write a 0. So what do I mean by A star B being equal to 0? This means A plus B plus AB is 0. Now this means what? B 1 plus A equals minus A, or I can say B is minus A upon 1 plus A. That means corresponding to every A in the set, there is a B occurring of this particular picture such that A star B is 0. But I am going to say that this B is the valid inverse of this A only when this B is going to come from this set. Because I have to show inside this set every element A has an inverse. So definitely B is playing the role of inverse in every manner. It is actually satisfying this property. It is coming out to be dependent on A. So definitely B is qualifying somewhere to be an inverse, but the only thing left out which is stopping me to declare it to be an inverse is that it's a dicey situation whether this B is coming from R minus 1 or not. Two things needs to be verified over here. One thing, that B is a real number. Secondly, it is a real number not equal to minus 1. These are the two things which we need to verify, which are going to prove that this B is coming from this set. So if I wish to do that, how should I proceed? Well, over here, when do you think will B not be a real number? Well, B will not be a real number only when the denominator is 0. But the denominator is 0 only when A is minus 1. But A is coming from R minus 1, that means A can never be minus 1. So, as A is coming from R minus 1, This means that A can never be minus 1, which means 1 plus A can never be 0. This means this is always going to turn out to be a real number. It is never ever going to give you an undefined term. So, B always is a real number. So, halfway we are through. The only thing left to show is that B is okay a real number, but it is not equal to minus 1, because only then can this B can belong to R minus minus 1. So, if B is equal to minus 1, this means minus A upon 1 plus A is minus 1. Suppose it is minus 1. This means what? Minus A equals minus 1 minus A. This means what? Minus 1 equals 0. The moment you have obtained this, this is a clear-cut contradiction, and therefore it is a surety that this B is coming from R minus minus 1, and therefore this B is the B which is not just a real number making this happen, but in fact it is a not equal to minus 1 real number, and that is why I can say B is the inverse of A, and because A was an arbitrary element chosen from R minus minus 1, and corresponding to this arbitrary A, I am getting an inverse B in R minus minus 1. Therefore, every element of R minus minus 1 is invertible. That is how you need to deal with this question, and that completes my discussion about the basically two questions in the very first question. So note this down, understand this, spend time with it, and then we are going to watch over the next question. Okay students, now it's turn for the next question. Just take a look at it and try and feel what is the concept that is being used over here, and then we are going to do it and deal with it together. Okay friends, so could you understand what this question is demanding from you? Well, the question is regarding probability, as you must have guessed by now. There are 5 cards numbered from 1 to 5. Okay, 5 cards numbered from 1 to 5. One number on one card. 2 cards are drawn at random without replacement. The moment I am saying without replacement, that means once I am picking up one card, I am not putting that card again, okay, so that that card can be picked once again, okay. So I am not replacing the cards. So 2 cards are drawn at random without replacement. Let X denote the sum of the numbers on the 2 cards drawn. Find the mean and the variance. So it's not just related to probability, it's related to something more, it's related to the mean and the variance. So basically that is what we need to find. So here if I am saying, if I should start my solution, I'll say let X denote the sum. So X denote the sum of the numbers on 2 cards. So let X denote the sum of the numbers on the 2 cards. Okay, fine. If X is denoting the sum of the numbers on the 2 cards drawn, that both the cards are ranging from 1 to 5. So the sum can range from where to where? The minimum the sum can be is 3, because 1 plus 2 or 2 plus 1 is 3. and the maximum the sum can be is 9, 5 plus 4 or 4 plus 5. So, then x can assume values 3, 4, 5, 6, 7, 8 and 9. Now I am interested in this, that is probability of getting 3 as the sum. Now when can I get 3 as the sum? When I am drawing 2 cards without replacement. From this set of 5 cards, each of the card is numbered from 1 to 5. So I have withdrawn one card, then I have kept it with myself, suppose, and then I have withdrawn another card. And I want the sum is coming out to be 3. Now the sum can come out 3 is what? When can the sum come out to be 3? So if I am getting 1 in the first draw and 2 in the second draw, or getting 2 in the first draw and 1 in the second draw. So what is this? Well, basically, if I am saying probability of getting 1 in the first draw or 2 in the second draw. So 1 in the first draw means what? Now 1 is written on exactly one card and there are totally 5 cards. So my favorable outcome is 1 and the total number of outcomes are 5. So probability of getting 1 in the first draw is 1 by 5, or probability of getting, and 2 in the second draw. So now 1 has come in the first draw. That means now I am left with just 4 cards. To get 2 in the second draw, that means only one card has 2 written on it. So this will be 1 by 4. Or means there will be a plus over here. Getting 2 in the first draw, again 1 by 5, because there is only one card on which 2 is written, and if that is coming in the first draw, that means in the first place we have 5 available outcomes with us. So 1 by 5 is the probability of getting 2 in the first draw and 1 in the second draw. So that makes the denominator 4, 1 less than 5, because I am not replacing my cards. Okay. This brings me to which result? This brings me to 1 by 20 plus 1 by 20, which is 2 by 20, which is 1 by 10. So probability of getting x equals 3 or the sum equals 3 is 1 by 10. Let's see what is probability of x equals 4. That means x can come out to be 4, the sum can come out to be 4 when 1 is drawn, or 1 comes out in the first draw and 3 comes out in the second draw, or 3 comes out in the first draw and 1 comes out in the second draw. Mind it, I cannot get 2 and 2 again. So once I am getting 2, I cannot get 2 again because that 2 has been withdrawn now and it is not being replaced. So 2, 2, getting 2 in the first draw, getting 2 in the second draw, that is not possible. That is why 2, 2 which makes a 4 is the very possibility which is not going to be covered over here. Either you can get 1 in the first draw and 3 in the second draw, or you can get 3 in the first draw and 1 in the second draw, which again makes my probability 1 by 10. Because again it will be exactly the same, 1 by 5 into 1 by 4 plus 1 by 5 into 1 by 4, which makes it a 1 by 10. If I talk about this, now this can happen in more than just one way. Well, 5 can occur when? So if 2 comes out in the first draw, 3 comes out in the second draw. So 2 comes out in the first draw, 3 comes out in the second draw, 3 comes out in the first draw, and 2 comes out in the second draw, plus 1 comes out in the first draw, 4 comes out in the second draw, plus 4 comes out in the first draw, and 1 comes out in the second draw. So this is going to give me 1 by 10 plus 1 by 10, which is 2 by 10, which is 1 by 5. Then what is probability of x equals 6? Again 4 plus 2 is 6 and 5 plus 1 is 6. So getting 1 in the first draw, 5 in the second draw, 5 in the first draw, 1 in the second draw, 2 in the first draw, 4 in the second draw, 4 in the first draw, 2 in the second draw. Add all them up, exact same expression. This is what you're going to get. If I talk about probability of x equals 7, again 3 in the first draw, 4 in the second draw, 4 in the first draw, 3 in the second draw, 5 in the first draw, 2 in the second draw, 2 in the first draw, 5 in the second draw. That is again going to deliver me with this. What is the probability of getting the sum equals 8? 5 in the first draw, 3 in the second draw, and 3 or 3 in the first draw, 5 in the second draw. That is it. And therefore, I am going to get a 1 by 10 because it resembles this particular expression. So, next is the probability of x equals 9, 5 in the first draw and 4 in the second draw, or 4 in the first draw and 5 in the second draw. That's it. So, again you are going to get a 1 by 10. Thus, probability distribution of x is as follows. How? Well, here you are going to write xi and here you are going to write pi. What is xi? The first xi is 3, then you have a 4, then you have a 5, then 6, then 7, then 8, and the last is 9. What is the probability of the first xi, which is x1, which is 3? It is 1 by 10. Probability of x equals 4, it is again 1 by 10. 5 is 1 by 5. 6 is again 1 by 5. 7 is again 1 by 5. And 8 and 9 are again 1 by 10, 1 by 10 each. And once you have this, let me now begin with calculation of mean and variance. For this, all you need is this probability distribution table. So let me rub all this so that we can draw this in an elaborative form. Let's get started. If I wish to calculate this, what all do I need to do? Well, I need a column of xi's, then I need a column of pi's, then I need a column of xi into pi, or I should say pi into xi, and then I would need pi xi square. Let's get started. Xi can be what? A 3. What is pi? For xi equals 3, pi is 1 upon 10. So pi into xi gives you a 3 upon 10 and xi square will be 9. 9 into pi, that is 9 upon 10. That's what you have to do. Next xi is 4. For 4 you have again pi to be 1 upon 10. So pi xi brings with you 4 upon 10. What is 4 squared? That is 16. So you get a 16 upon 10. After this you have a 5. Here it is 1 by 5. So you get 5 into 1 by 5, which is 5 by 5. And here if you square this is 25. So this gives you 25 by 5. Next, what is it? 6. 6, and here you have again 1 by 5. So this gives you 6 by 5 and here you have 36 by 5. Then 7. 7 again it is 1 by 5. This gives you 7 by 5 and here you have 49 by 5. Then you have 8. This is 1 by 10. This brings with you 8 by 10 and here you have 64 by 10. Here you have 9. For 9 again you have 1 by 10. This is 9 by 10 and here you have 81 by 10. That is what you do. Once you have accomplished this table, now we need to find out the mean and the variance. So what is the mean? Mean given by this particular symbol is summation xi pi, I going from 1 to, so x1, x2, x3, x4, x5, x6, x7. So from 1 to 7. What do you think this is? So summation pi always comes out to be 1. If you wish to calculate summation pi xi, I going from 1 to 7, you are going to find this is coming out to be 6. And when you find out summation pi xi square, you will see this is going to come out to be 390 upon 10, which makes it a 39. So over here your mean is 6. And what is your variance? It is summation pi xi square minus summation pi xi whole square, right? So summation pi xi square is 39 minus summation pi xi is 6. 6 square is 36. So you get 3 to be the variance. So you have found your mean and your variance, and that completes my discussion about this question. Well, first of all, you had to find out the probabilities of each of the sum occurring from 3 to 9. That is what is the first thing that we found. After that, we made a probability distribution table, which basically helped us in making this large table, which was helpful to calculate the mean and variance. Just the knowledge of the formula of mean and variance and this table helped me to get the exact values of mean and variance, and that completes my question. Very easy, very direct question. Just you have to apply the formula of mean and variance, and whatever the formula is requiring, just find all that out and you have your answer with you. That is how you need to deal with this question. Spend some time with it and then we are going to move to the next question. Okay students, now we have moved to the next question. Just take a look at the next question and see what it is. It's something super easy, just calculations required. Could you understand what the question is demanding? Well, something very easy, very nice has come your way. Elementary row transformation. That's it. So it is saying using elementary row transformation, find out the inverse of this matrix. I think this is one of the most common interesting topics for students. This is something very easy. It always is asked in the exams, and so I am not going to solve it completely. It is completely your own task. Let me just give you a hint how that's done. What you do is the first step to apply elementary row transformation is to consider this equation. This is true. Any matrix is equal to identity times itself, right? Because on taking product with the identity matrix, the identity of the matrix A is not changed, it remains the same. Next, what you do is you copy down the matrix A, which it is. It is 3 minus 1 minus 2, after which you have 2, 0 minus 1, after which you have 3 minus 5 and 0. So A is equal to identity, which is 1 0 0 0 1 0 0 0 1. Identity times the matrix A. What you have to do is you have to apply the row transformations in order to make over here the identity matrix. And the moment you get over here 1 0 0 0 1 0 0 0 1, by the time you get here as identity, over here you're going to get an entirely new matrix which will be nothing but your A inverse. So you have to apply or basically incorporate row operations in such a way that here you get a 1, here you get a 0, here again you get a 0, here 0, here 1, here 0, and here 0, here 0, here 1. That is what your task is, something super simple. So let me just do 1 or 2 operations for you and then give you a hint as to how this is done. So firstly, what you can do is, according to me, you can say row 1 goes to row 1 minus row 2. Suppose I do that. What gives me? Now row 1 goes to row 1 minus row 2. So 3 goes to 3 minus 2, which gives me a 1. Then minus 1 minus 0 gives me minus 1. Minus 2 minus minus 1 gives me minus 2 plus 1, which is minus 1 again. And rest of the entries remain the same. Isn't it? Over here on the other hand, if I proceed, what is it that I am going to get? Well, row 1 goes to row 1 minus row 2. So 1 minus 0 remains 1. 0 minus 1 and 0 minus 0. So like this you just keep on doing. Basically over here I have successfully obtained a 1. Over here now I want a 0, then again a 0. Over here also I want a 0. So what am I going to do is, I am going to now do the operation that row 1 goes to minus 2 times row 1. And once this is done, next I am going to do is row 2 goes to row 2 plus this new row 1. What is going to happen when I do this? Okay, so row 1 goes to minus 2 times row 1. So this becomes minus 2, this becomes 2, this becomes 2, isn't it? Then you have, these remain the same, exactly same. Then you have row 2 goes to row 2 plus this new row 1. So 2 plus minus 2, 0 plus 2, minus 1 plus 2, and here you have 3 minus 5 and 0, after which what you can do is you can just take out this common and again get back the same inputs. That's what I've done, and now by these operations I have obtained a 0 over here and 1 over here. Okay, so this is how step by step you have to do. When you do the same thing on the right hand side, what is it that you obtain? Well, the first thing you did was you multiplied minus 2 over here, so you get minus 2, then you get a 2 and then you get a 0. Then this 0 is added to minus 2, gives you another minus 2. 1 is added to 2, gives you 3, and 0 is added to 0, this gives you 0. And the last row remains the same, right? Here again you're going to get 1, minus 1 and 0. You can just take out 2 common. Now over here, if you have got this, one more step which can be done, after which I am going to stop this, is that you can say rho 1 goes to minus 3 times rho 1. So over here you are going to get minus 3, and then you are going to say rho 3 goes to rho 3 plus rho 1. So by doing that you will get minus 3 over here. 3 plus minus 3 is going to deliver you a 0, and that's how you are going to get 1, 0, 0. And if you are going to do the same thing here, this entire matrix will similarly in a respective manner will get manipulated. So this is how you can continue doing the operations, applying the operations. This is something very, very easy. You can just feel what is supposed to be done and you can keep on doing. And therefore you can get 1, 0, 0, 0, 1, 0, 0, 0, 1. If one fish is like moving in this direction, you can also start by showing 1, 0, 0, 0, 1, 0, 0, 0, 1. Whichever is convenient to you. I am right now moving in this particular vertical sense direction. That is falling to be easy according to me. That's why I am leaving this, because this can happen according to your discretion. You might come up with a lesser number of steps and then obtain the same output. I might be involving more number of steps, who knows? So that is why you have to do it by yourself, just following the exact same lines, and you are going to get your inverse. So what is going to come is, then here you are going to have 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? And over here, what is it that you are going to get? Now this was my A, and I have converted this left hand side into the identity matrix. So over here, in place of the identity matrix, whatever I am going to get will be my inverse matrix. So what will that be? Minus 5 by 8, 5 by 4, 1 by 8. Or basically, let me write it over here. Very easy question sometimes, or I should say each and every time it's asked in the paper. You are going to obtain this A inverse to be equal to, or basically I should not write A inverse, it should rather be written as I was writing 1, 0, 0, 0, 1, 0, 0, 0, 1. You're going to get, this is going to come out to be minus 5 by 8, 5 by 4, 1 by 8, minus 3 by 8, 3 by 4, minus 1 by 8, minus 5 by 4, 3 by 2, and 1 by 4. This into your matrix A. And this is what is your A inverse, which you have obtained, which you will be obtaining by the row transformations. By those row transformations, you converted this left hand side, which was A, into the identity matrix. So you get identity is equal to A inverse into A. Because if A is getting multiplied to a matrix to give you identity, that matrix has to be the inverse of A, and this is the logic which we use to basically find the inverse of a matrix A. So once I am done with this, let us now focus on the alternate question. What is being said in the alternate question? Now here the question was asking you to find out the inverse by using elementary row transformation. Here on the other hand, again it is saying to find A inverse, but now not through elementary row transformation. We are going to use a very general basic property to find the inverse. We know that A inverse is equal to adjoint of A upon determinant of A, provided determinant of A is non-zero. If determinant of A comes out to be 0, my matrix is singular and hence non-invertible. So the first thing that I am going to do is to find out the determinant of A. which is the determinant of 1, 2, minus 3, 2, 3, 2, 3 minus 3, minus 4. Now, along this particular first row, let's start opening up. You're going to get 1. 3 into minus 4 gives you minus 12. Minus 6. Okay? Then you have a minus 2, you get minus 8, minus 6. Plus you have a minus 3, so let me write minus 3. Then you have a minus 6, minus 9. After this, you're left with what? Minus 12 plus 6 gives you minus 6. Minus 8 minus 6 is what? Minus 14. What is minus 14 into minus 2 is going to give you a plus 28. And here you are left with minus 6 minus 9, which gives you minus 15. Minus 15 into minus 3 gives you plus 15 into 3. Because this minus comes together to make a plus. So what is it that you get? You get minus 6 plus 28 plus 45, which gives you what? You can calculate this. This comes out to be 67, I suppose. 67, and this is definitely not equal to 0. The moment you find determinant to come out to be a quantity not equal to 0, what is it next that you can say? If this quantity, whatever is it, comes out to be not equal to 0, which it is coming out to be, that means the matrix A is non-singular and therefore A inverse definitely exists. If your A inverse is definitely existing, what is that going to be? Now, A inverse is adjoint of A upon determinant of A. Correct? Once you have this, let's focus on adjoint of A, because determinant of A is calculated through this formula. So adjoint of A is what? Transpose of all the cofactors of A. So let's find out the cofactors of A. C11 minus 1 to the power 1 plus 1, which is 2, into determinant of, now this 1 quantity is fixed, 3 into minus 4, or I can write 3 minus 4, 2 minus 3, which gives you what? 3 into minus 4 is minus 12 plus 6, which makes it a minus 6. Because 3 into minus 4 is minus 12 minus 6, which makes it a plus 6. So here you have C12 next, which is minus 1 to the power 3, which makes it minus 1. So 1, 2. So first row, second column, you have 2 into minus 4, which is minus 8. So 2 into minus 4 is minus 8, minus 6. You get a positive 14. Then you have C13. So C13 delivers you with a 1, because minus 1 to the power 4 is 1. First row, third column, you get minus 6, minus 9. Which gives you minus 15. Then you have C1 or C21, I should say. Second row, first column. Now, the moment you've packed second row, first column, you have minus 8, minus 9. And outside you have minus 1 to the power 3, which makes it minus 1. And you get a 17 in picture. Because minus 8 minus 9 is minus 17 into minus 1 is 17. What is C22? What is this? This is second row, second column. So you get 1 into minus 4, which is minus 4 plus 9, which makes it 5, because minus 1 to the power 4 is 1. Next you have C23, second row, third column. So second row, third column is fixed, you get minus 3, minus 6 into minus 1, so you get a 9. After this you have C3, 3, 1. Third row, first column, this gives you 4 plus 9, which gives you 13. C3, 2. Third row, second column, this gives you 2 plus 6, which is 8, or I should say minus of 2 plus 6, which gives you minus 8, because minus 1 to the power 5 is minus 1. Then you have C3, 3. So third row, third column. So you have 3 minus 4, which is minus 1. And that means you have got your adjoint of A as transpose of which matrix? So what is C11? This is minus 6. C12 is 14. C13 is minus 15. C21 is 17. C22 is 5. C23 is 9. C31 is 13. C32 is minus 8 and C33 is minus 1. Its transpose is what is your adjoint of A. Once you are through with finding the adjoint, which is nothing but, what is it? Transpose, just take the transpose, you get minus 6, 14, minus 15, then you have 17, 5 and 9. Then you have 13, minus 8, minus 1. Once this is there, you know what is your A inverse. It is adjoint of A upon determinant of A. Quickly find out what this entire matrix is going to turn out to be, and then I am going to come and give you the final answer. Okay, so as we had found the determinant, it was coming out to be 67. The moment determinant is with us and the moment adjoint of A is with us, we can very nicely find out what is adjoint of A upon inverse or determinant of A. So that gives me 1 by 67, this entire matrix, minus 6, 17, 13, 14, 5, minus 8 and minus 15, 9 and minus 1. This happens to be my A inverse matrix. The moment this is done, the question is not only asking this much, the question is also asking something else. It is saying once you have found A inverse, hence solve this system of equations. Let's see what is being said in this system of equations and how is A inverse useful in finding it out. The system of equations is x plus 2y minus 3z equals minus 4. Then you have 2x plus 3y plus 2z equals 2. And then you have 3x minus 3y minus 4z equals 11. Now obviously this can be written as Ax equals B, where what is your A? The coefficient matrix. 1, 2, minus 3, 2, 3, 2, 3 minus 4. This is the exact same matrix which is given over here. And your x is x, y, z, and your B is the column vector minus 4 to 11. Fine. Also I know that this is non-singular because I know its determinant was 67, which is not equal to 0, and this implies A inverse exists, which I know what is it, we have just found, and therefore the solution of this system of equations is given by x will be equal to, which is this, is what? It is nothing but A inverse B. That is why the inverse was needed to solve this system of equations, because the solution of this system of equations is the product of A inverse and the matrix B. So for that you need A inverse, which is what? 1 by 67 into minus 6, 17, 13, 14, 5, minus 8, minus 15, 9, minus 1 into minus 4, 2, 11, and that gives me this column vector as the result. And therefore you get that your x is equal to this column vector, which is 3, minus 2 and 1, and therefore your small x is 3, small y is minus 2 and small z is 1, and that is how I have solved this system of equations with the help of inverse of this matrix. Because I had my inverse, which was obtained by the formula adjoint of A upon determinant of A, I just used that inverse to solve the system of equations, and that is how this question is dealt with. Practice this very nicely, and then we are going to move to the next question. Okay students, let's start dealing with the next question. Very interesting section concerning of linear programming problem. Just take a look at it. Try and understand what the question is demanding, and then we are going to deal with it. So could you understand what this housewife is trying to do? Well, there is a housewife which wishes to mix together two kinds of foods. So X is a kind of food, Y is another kind of food, in such a way. That means there are certain units of the food X, certain units of food Y, which are mixed together to form a mixture, such that in that mixture contains at least 10 units of vitamin A, 12 units of vitamin B, and at least 8 units of vitamin C. The vitamin contents of 1 kg of food are given below. So 1 kg of food X contains 1 unit of vitamin A, 1 kg of food Y contains 2 units of vitamin A, 1 kg of food X contains 2 units of vitamin B, 1 kg of food Y contains 2 units of vitamin B, 1 kg of food X contains 3 units of vitamin C, and food Y, 1 kg of food Y contains 1 unit of vitamin C. 1 kg of food X costs rupees 6 and 1 kg of food Y costs rupees 10. Find the least cost of the mixture which will produce this particular diet. So least cost, this is what I need to focus on. So what do I need to find? Basically, I need to find how much, how many kilograms of food X should I take and how many kilograms of food Y should I take, so that when they are mixed up, I get all these constraints being satisfied such that the cost is minimum. So let X kg of food X and Y kgs of food Y be mixed to form the mixture. Okay? Now, if 1 kg of food X contains 1 unit of vitamin A and 1 kg of food Y contains 2 units of vitamin A, that means X kgs of food X contains, and X kg of food X and Y kg of food Y contains X plus 2Y units of vitamin A. Fine, that's the first thing that I have found. If 1 kg of food X contains 1 unit of vitamin A, 1 kg of food Y contains 2 units of vitamin A, so X kgs of food X and Y kgs of food Y are going to contain X plus 2Y units of vitamin A. But this is the vitamin A inside the mixture, right? And inside the mixture I want at least 10 units of vitamin A. So this has to be greater than equal to 10. Next thing, let's focus on vitamin B. If 1 kg of food X contains 2 units of vitamin B, 1 kg of food Y contains 2 units of vitamin B. So, X kgs of food X and Y kgs of food Y contain 2X plus 2Y units of vitamin B. But inside the mixture, I want at least 12 units of vitamin B. So, this content has to be greater than equal to 12. If I have 1 kg of food X contains 3 units of vitamin C, 1 kg of food Y contains 1 unit of vitamin C. So, X kgs of food X and Y kgs of food Y contain 3X plus Y units of vitamin C. And vitamin C content in the mixture has to be greater than equal to 8. Also, because X and Y are quantities of food, they can never be negative, they will always be non-negative. So, the linear programming, or I should say, the linear programming problem is what? Before that, in order to get this particular linear programming problem, I need to focus on the amount. So, here it is written 1 kg of food X costs rupees 6 and 1 kg of food Y costs rupees 10. So, X kgs of food X and Y kgs of food Y cost rupees 6X plus 10Y. And my aim is to minimize this cost. So, basically my objective function is to minimize, I should say minimize Z, which is equal to 6X plus 10Y, subject to what all constraints? All these constraints, which are X plus 2Y is greater than equal to 10, 2X plus 2Y is greater than equal to 12, 3X plus Y is greater than equal to 8 and X is greater than equal to 0, Y is greater than equal to 0. So, let's get started with this. Well, I am supposed to plot certain things in order to get the feasible region. You have to draw the line X plus 2Y equals 10. That is the first thing we are interested in drawing. X plus 2Y equal to 10. Put X equals 0, you obtain Y equals 5. So, you get 0, 5. This is your point, 0, 5. And if you put Y equals 0, you get X equals 10. So, this is 10, 0 and you get that this is your very line X plus 2Y equals 10. Okay. Let's focus on the next line, 2X plus 2Y equals 12. Put X equals 0, you get Y equals 6. Put Y equals 0, you get X equals 6. And so, the line that you obtain is this. And this is the line 2X plus 2Y equals 12. After that, you have 3X plus Y equals 8. So, put X equals 0, you get Y equals 8. Then you put Y equals 0, get X equals 8 by 3. And so, this is what you obtain as the line, which is 3x plus y equals 8. You know how to find out these intersecting points as well. What is this? This point is 1, 5 and this point is 2, 4. You can just find out the points where two lines are intersecting and you will be able to get these points very easily. The question is, which is the feasible region? So the first line which we drew was x plus 2y equals 10. I want greater than equal to 10. That means my feasible region is this one. The second constraint said this has to be greater than equal to 12. So this is what my line is. Greater than equal to this means this region. After this, the third constraint said 3x plus y is greater than equal to 8. Okay, so this is being said. So what is the common region? The common region is given by this region. Yes, the blue boundary of this region is what is the region which is the feasible region. After that, what you do? You collect the corner points. What are the corner points? You have 0, 8, then you have 1, 5, then you have 2, 4 and then you have 10, 0. And over here, value of z, which is equal to 6x plus 10 y. So 6 into 0 plus 10 into 8 gives you 80. 6 into 1, which gives you 6, plus 10 into 5, 50, which makes it a 56. Then you have 6 into 2, which is 12, plus 4 into 10, which is 40, which gives you 52. And then you have 6 into 10 plus 10 into 0, which is 60. And you can see that among all of them, 52 is the least cost. So the least cost is rupees 52 when 2 kgs of food X and 4 kgs of food Y is mixed or is taken. So what is my apt amount of X and Y quantities? Well, I should take 2 kgs of food X, 4 kgs of food Y, such that all the constraints are satisfied and in fact the cost is minimum. That's how you deal with questions coming from linear programming problems. Note this down, understand how I have solved it, and then be prepared for the next question. Okay students, so we did not deal with the alternate question which is also there. The LPP question is always asked in the exam, so you better practice this, but this time in this paper, we have an alternate question to this coming from the increasing decreasing section. Take a look at it and then we are going to deal with it. So alternatively to this linear programming problem, you have this particular section of problem which is saying separate 0, pi by 2 into sub-intervals in which the function sine 3x is increasing or decreasing. Again, the increasing decreasing concept is dealt with the derivative, single derivative f dash x. Wherever f dash x is greater than 0, we declare the function to be increasing for those particular x's. And for x's for which f dash x is less than 0, we say for those x's, function is decreasing. So let me start with seeing what is my f dash x when fx is sine 3x. If fx is sine 3x, f dash x is what? Cos 3x into 3. So this gives me 3 cos 3x. Now if I wish to find out where is f dash x greater than 0, where is f dash x less than 0, I need to be very aware about the behavior of the cos function. If you remember, we had done this sign convention ASTC. In the first quadrant, all trigonometric functions are positive. In the second one, only sine and cosec are positive. Third one, tan and cot are positive. Fourth one, sec and cos are positive. That means in the first quadrant, cosine is positive. In the second quadrant, cosine is negative. In the third quadrant, cosine is negative. So, this is your pi by 2. This is your pi. This is your 3 pi by 2 and this is your 0. So, once this is clear, I know that if my x is allowed to come from 0 to pi by 2 closed interval, that means x is greater than equal to 0, less than equal to pi by 2. So 3x is greater than equal to 3 times 0, less than equal to 3 pi by 2. If 3x is ranging from 0 to 3 pi by 2, that means this angle is ranging from 0 to 3 pi by 2. That means cos 3x will be what? Well, when 3x is ranging from 0 to pi by 2, cos 3x is positive. So 3 cos 3x is positive. But when 3x is ranging from pi by 2 to 3 pi by 2, that means cosine, the angle is in second or the third quadrant. So the cosine of 3x, the cosine ratio of all these angles will be negative. So 3 times cos 3x will also be negative. So f dash x will be negative. That is what is basically the outline of the entire proof. Because the moment I am saying 3x is from 0 to 3 pi by 2, my entire proof is divided into two cases. When 3x is ranging from 0 to 3 pi by 2, if 3x is from 0 to pi by 2, if it is in this section, this means what? Cos 3x is strictly greater than 0. It is positive, which implies 3 cos 3x is also positive, but 3 cos 3x is what? It is nothing but f dash x. F dash x is positive. That means f dash x is positive for all x, or I should say for all 3x greater than equal to 0, less than equal to pi by 2. Which implies for all x greater than equal to 0, less than equal to pi by 6. So I have f dash x is greater than 0 for these x's. This is 0 to 30 degrees. So from 0 to 30, in the entire interval of 0 to 90, from 0 to 30 corresponding to these angles, corresponding to these points, f dash x is positive, and so I can say f is increasing in this subinterval. Okay, this is a subinterval of 0 to pi by 2. Whereas if I consider my case 2, in which now I am allowing 3x to move from pi by 2 to 3 pi by 2. That is when 3x is greater than equal to pi by 2 and less than equal to 3 pi by 2. That means when the angle is ranging in the second or the third quadrant, definitely cos of that angle will be negative, because 3 is a positive quantity, so 3 times cos 3x will not change the inequality. But this is nothing but f dash x, so I get f dash x is negative for all x, or I should say for all 3x greater than equal to pi by 2 less than equal to 3 pi by 2, which means f dash x is less than 0 for all x greater than equal to pi by 6 less than equal to pi by 2. Yes, this means f is decreasing on the subinterval pi by 6 to pi by 2. So I was asked that I am given the interval from 0 to pi by 2. I had to show if the inputs are coming from this set, divide it into subintervals and tell me which is the subinterval over which the function is increasing and over which it is decreasing. So I made a pi by 6 over here. I said in this section from 0 to pi by 6, the function is increasing, and from pi by 6 to pi by 2, I had that my function is decreasing. So therefore, I have divided my interval 0 to pi by 2 into two subintervals, one over which it is increasing and the other over which it is decreasing. Note this down and then we will move to the next question, because that is how you deal with these questions of increasing, decreasing. So spend some time with it and then come with me in the next question. Okay, so now that we have dealt with that question, now I have another question for you. Take a look at it. It's something very simple, very easy. Again, one topic over which every time a single question is definitely asked. Take a look at it. What is this? Isn't this related to the area of bounded regions? Right? Regions which are bounded, those regions area is what we have already studied, and over that the question is being asked. So let's see what the question says. Using integration, find the area of the region bounded by this line, and the lines x equals 2 and x equals 4. Okay, this is what we have to find out. So let's see what the figure turns out to be. What is that region whose area I have to find? The first line given to me is 2y equals minus x plus 8. If I take x equals 0, I get y equals 4. So this is what I get. Take x equals 0, get y equals 4. If I take y equals 0, I get x equals 8. And then what I do is I simply join these 2 points to obtain my line, which is 2y equals minus x plus 8. This is that line. Then you have x-axis. Okay, so you have your x-axis. Okay, then you have your line x equals 2. So this is your line x equals 2. Then you have x equals 4. That is what you have in picture. That means the area bounded by this line, x-axis, x equals 2, x equals 4, which is this area. This is what you need to find. So if this shaded region is sliced into rectangles, you can see that if I slice this into rectangle, the lower end of the rectangle touches the x-axis and the upper end of the rectangle touches the line 2y equals minus x plus 8. This means the length will be y and the breadth will be delta x. And so the area of this rectangle will be length into breadth. Also, this approximating rectangle can move, this is vertical rectangle, so this can move from x equals 2 to x equals 4, and therefore your required area is from x equals 2 to x equals 4 y dx. And what is this y? Well, basically this point is lying on the line. This line is 2y equals minus x plus 8. So y is minus x plus 8 divided by 2. Okay? Once you know this, you can take out 1 by 2 common. What are you left with? You have minus x plus 8. So this gives you minus x squared by 2 plus 8x from 2 to 4. Isn't it? This is minus x squared by 2 plus 8 into x. Just integrate it from 2 to 4. So you get 1 by 2 into minus 1 by 2 into x square from 2 to 4. So this gives you 16 minus 4 plus 1 by 2 into 8, 4 minus 2. So what is it that you get? You get minus 1 by 4 into 12 plus 4 into 2, that is 8. So you get 8 minus 3, which is 5 square units as your answer. This is what is your answer, which is 5 square units. The area of this shaded region is 5 square units. That is how I have dealt with this question. Basically understand firstly to draw the line. What is the question saying? To basically consider the region bounded by this line x equals 2, x equals 4 and the x-axis. So I got this region, then I drew this rectangle. Vertically I sliced this shaded portion. The rectangle can move from x equals 2 to x equals 4, and so I applied my limits over x. I varied my x, thereby plugging in the value of y, and therefore after solving this I have obtained the answer, which is the area of this shaded region. Understand this, note this down, and then we are going to deal with the last question. Okay friends, let's deal with this last question. Just take a look at it. Something very simple. Just remember what are the concepts which are going to be used to do this, and you can sail through this question. The question is saying, show that there are 4 points 0, minus 1, minus 1, minus 4, 4, 4, 4, 5, 1 and 3, 9, 4. Show that these 4 points are coplanar. That means they are lying on the same plane. In fact, find the equation of the plane on which these 4 points are lying. So let me pick up one point at a time. If I say that I am focusing my attention on just this point, which is 0, minus 1, minus 1, then the equation of the plane passing through the point 0, minus 1, minus 1 is given by what? Well, if you remember, the equation of the plane passing through this point is given by a into x minus 0 plus b into y minus minus 1 and c into z minus minus 1 equals 0. This is how the equation of the plane passing through this particular point is given by. Now, if the same plane passes through this point and this point as well, that means it basically contains this and this point as well. That means these 2 points are going to satisfy this equation of the plane. So, minus 4, 4, 4, substitute in place of x. If minus 4, 4, 4 and 4, 5, 1 also lie in this plane. This implies what? What does this imply? So in place of x, y and z, I am going to substitute one by one these three coordinates and then these three coordinates. So I am going to get a times 4 or a times minus 4 plus b times y plus 1, so 4 plus 1, that is 5, plus c times z plus 1, which is 4 plus 1, which is again 5. And if this point is also lying in the plane, that means it is going to satisfy the equation of the plane. So this will be a times 4 plus b times y plus 1, so 5 plus 1, which is 6, plus c times z plus 1, which is 1 plus 1, which is 2. So this can be transformed to a times 2 plus b times 3 plus c times 1 is 0. You can just take out 2 common, so you're left with 2 over here, 3 over here and 1 over here. Now you consider this and this. And these two equations, when you consider by cross multiplication, what is it that you get? By cross multiplication, the technique is you write A, B and C. Now, you fix the first column. You take 5 into 1 minus 5 into 3. Okay? Then you fix the second column. You have 5 into 2 minus 4 into 1. So, you have 5 into 2 plus 4. Isn't it? That's what you have. Once you have fixed this second column, you get 5 into 2 minus 4 into 1. So 5 into 2, that's 10, minus 4, which is plus 4, which makes it 14. And once you have fixed the third column, you have minus 4 into 3 minus 5 into 2. So minus 4 into 3 minus 5 into 2. Isn't it? That's what you get. So this gives you a upon minus 10 equals b upon 14 equals c upon minus 22. And suppose all of this is equal to lambda. Then you get a is equal to minus 10 lambda, b is equal to 14 lambda and c is equal to minus 22 lambda. That means you have your values of a, b and c with you. You just needed the values of a, b and c to plug in over here to get the equation of the plane, which is containing the 3 points. This point and this point. That's how we have started the construction. So I just needed a, b and c's value to plug in over here to get the equation of this plane. I have got this values of a, b and c. So substitute values of a, b, c in star if I say that this is star. Why don't you substitute and see what is it that you are getting, and then I am going to come and complete the answer. So did you substitute the values of a, b and c in the equation of the plane? Well, over here if you carefully observe, you can see there is 2 coming out common from each of a, b and c. So if at this particular step, like from here also you can proceed, but in order to get a more simplified answer, if you take a upon minus 5 equals b upon 7 equals c upon minus 11, if this you take, that is going to come out to be twice of some constant number. Take that to be equal to lambda. What is the problem? Even these quantities are equal if these quantities are equal, right? That is what proportion means. And so take this to be equal to lambda. And so here, from here you get a is minus 5 lambda, b is 7 lambda and C is minus 11 lambda. Now if you substitute all these simplified values easier than before, over here what is it that you get? You get minus 5 lambda into x plus b into y plus 1. So plus 7 lambda into y plus 1 plus c into z plus 1. This is equal to 0. Just open this up. You get minus 5x into lambda plus 7y into lambda minus 11z into lambda plus 7 lambda minus 11 lambda. Isn't it? That's what you get, minus 11 lambda z minus 11 lambda. This is equal to 0. You can take out lambda common throughout and you are going to get minus 5x plus 7y minus 11z plus 7 minus 11, which makes it minus 4. Or I can say 5x minus 7y plus 11z plus 4 is 0. This is the equation of the plane containing 3 points 0, minus 1, minus 4, 4, 4 and 4, 5, 1. The magic is that it is definitely going to contain the 4th point as well. You can try to plug in 3, 9, 4 in place of x, y and z, and you are going to get that the right hand side is coming out to be 0, which means this plane also is containing the 4th point. That means this is that plane which is containing all the 4 points, by which I mean that all 4 points are coplanar, lying on one single plane. An equation of the plane containing all of them is 5x minus 7y plus 11z plus 4 equals 0. And that completes my question. This is how you have to deal with questions coming from plane chapter. 3 points are enough to give you the equation of the plane. The 4th point automatically is going to satisfy that equation and hence lie in that plane, thereby giving you coplanar points and the equation of the plane containing those 4 points. That completes my discussion of the entire paper, in which basically we have practiced some very beautiful questions which are most frequent to being asked in your papers. Practice them very nicely, and as I was saying, focus on the ideas which were used to solve the question, the concept, the formulas, the underlying ideologies which were used in the question to solve it. And then once the idea is clear, the direction is clear, any question coming on that regard will be done by you. It will be cakewalk for you. So all the very best for your exams. I hope you're able to perform very well. Take care and goodbye.